Okay, so here we've got a statics problem. We've got a girder. It's suspended by two metal cables, and each cable has a tension in it of 850 newtons. And you can see we're given the angle between the cables and the girder. And we've been asked to work out the weight of the girder. Okay, so the first thing we've got to do here is we've got to resolve the tension in the cable, and we've got to resolve it into vertical and horizontal components. So we can do that using trigonometry. So if I draw on here the vertical component of this 850 Newton force, which is the tension in this metal cable, the vertical component is going to be there, like that, okay? So it splits into, we can split this into two components, the vertical component and then the horizontal component. And the horizontal component will be along this line here, okay? All right, you can translate that if you want, so that the horizontal component is along this line here, because we can just translate that up to here. Okay, so we want to work out this vertical component. So the vertical component of the tension in this metal cable. To do that, we know that this is a right angle triangle. So you can see that's a right angle triangle there. And we know that this is the hypotenuse. We know that this 42-degree angle is also 42 degrees there, okay, from similar angles, or sometimes we call them Z angles. If we've got a Z like that, and we've got 42 degrees in this, we've got 42 degrees there as well, okay? Or the other thing you could figure out is that if this is, we know that this angle here is 90 degrees, so if that's 42 degrees there, then this angle here must be 48 degrees, because it's 90 minus 42. Okay, but the point is that this is the hypotenuse. If we use this angle here, this will be the opposite, so let's just ignore that for now. And this will be the adjacent, okay? So the vertical component, to do that, we've got, if we've got opposite and hypotenuse, sine theta is equal to opposite over hypotenuse, okay? And we don't know what the opposite is, but we know that the hypotenuse here is 850 newtons. So we can put 850 in there. And I should have put the angle in there as well. So we can again write that sine 42 degrees is equal to, is equal to opposite over 850. So that O there is the opposite, it's not 0. Okay, so all we've got to do then is rearrange this. So if we rearrange this, we can see that the opposite is equal to 850 sine 42. So I've just flipped the two sides round. I've taken that up there. If it's a divide on this side, we bring it over this side, it becomes a times 850 sine 42. And that will give us our component there, our vertical component. So if we put that into the calculator, we can see that 850 sine 42 just gives us 569 newtons, okay? So that's our vertical component. Now, if we want to work out the horizontal component, then we do something similar. This time, this horizontal component here, which I've just translated up to there, is the adjacent to this 42-degree angle, and this is the hypotenuse. So we're going to use this time cos 42 is equal to the adjacent over the hypotenuse, which is 850. And then if we just rearrange that, we know that the vertical component, which is the adjacent in this case, sorry, the horizontal component, which is the adjacent in this case, is just going to be equal to 850 cos 42. And again, if you stick that into your calculator, 850 cos 42 gives you 632 newtons, okay? So we've now got the vertical component and the horizontal component. Now on this side, the situation is exactly the same. We've got a vertical component of 569 and we've got a horizontal component of 632. Now, because the whole system we know is in equilibrium, it's static, it's not moving. It's not moving, therefore we know that the resultant force on this object must be 0. Okay, now what you'll notice is that there are two horizontal components. Okay, so you've got these two horizontal components acting this way. The horizontal component of this force here is 632 newtons and the horizontal component here is 632 newtons. You can see that they are equal forces acting in opposite directions. Now, when we have equal forces acting in opposite directions on a particular object, we know that those two forces cancel out and the resultant of those two forces will be 0. So horizontally, the resultant force is 0. Now, vertically, we've got a vertical component of this 850 newtons here, which is 569 newtons, and we've got 569 newtons here, okay? Because we worked out that the vertical component here is 569, and on this side it's going to be the same. So those two forces are acting upwards. Now, what's the force acting downwards here? Well, they're the vertical component of the tension. The force acting downwards is the weight of the beam or the girder. And that weight's going to act in the center of this girder or this beam. Presumably this girder is a uniform object, so it'll act in the center. Now what we know is this thing is not moving, so the vertical forces on it must be in equilibrium. There must be 0 resultant force. So if we add these two vertical forces together, okay, so for weight of the beam is equal to 2 times 569 newtons, okay, because it's this plus this is the total vertical force upwards from the tension in these cables, and that's got to be equal to the downward force of the weight. So that's going to give you 1,000. So that's going to give you 1,138 newtons. Okay, so there you go. That's that one done.